Hello, everyone. In this lesson, let's learn the function and application of Programmable Logic Controller. In this lesson, we will start from the composition, recognition, wiring, and application of the Programmable Logic Controller. Through this lesson, I hope that everyone can, according to a practical case of using a PLC device, correctly complete the wiring of the PLC device, list the input-output allocation table, finish the wiring and power-on debugging of the PLC device, and experience the application of the Programmable Logic Controller (PLC). It can cultivate scientific thinking and sense of responsibility, and stimulate rigorous attitude and innovative spirit towards engineering and technical problems. Now let's learn the first part. Programmable controller is a device that realizes signal acquisition, signal processing, and output control in industrial field. It is mainly produced by Siemens, Mitsubishi, Inovance, and other companies. This course mainly takes Siemens Programmable Controller S7-200 Smart as an example to demonstrate. Let's review a real case. A machine tool equipment manufacturing factory, due to negligence in the wiring link of the Programmable Logic Controller (PLC), resulted in defects in the wiring of electrical components. Eventually, the equipment debugging encountered a failure that it could not be started. After in-depth investigation, it was found that the technicians failed to strictly follow the wiring standards and neglected the detection of some key links, which led to this consequence. This case profoundly tells us that as engineers and technicians, every decision and action we make is related to the quality and safety of products, and the safety of consumers' lives and property. Therefore, we must always maintain a high sense of responsibility and mission, treat every work step rigorously and seriously, and must not be sloppy or careless. Next, let's learn about Siemens Programmable Logic Controller S7-200 Smart together. The S7-200 Smart CPU integrates a microprocessor, an integrated power supply, and digital input-output points into a compact package, thus forming a powerful micro PLC, as shown in the figure. Hardware composition. The S7-200 Smart CPU module includes a central processing unit, CPU, power supply, and input-output points, all of which are integrated into a compact, independent device. CPU is responsible for executing programs and storing data in order to control industrial automatic control tasks or processes. Control points of the system at input and output. The input part collects signals from field devices, such as sensors or switches, while the output part controls pumps, motors, indicator lights, and other equipment in industrial processes. The power supply provides power support to the CPU and any modules connected to it. The communication port is used to connect the CPU with the upper computer or other industrial equipment. The status signal shows the CPU operating mode, the current status of the local input-output, and the detected system errors, etc. Wiring of PLC input-output ports. Sync input. The corresponding input device is of PNP type. High level is valid. Common cathode. The current flows into the input point. Source input. The corresponding input device is NPN type. Low level is valid. Common anode. The current flows out from the input point, as shown in the figure. Both the S7-200 Smart PLC and the EM Extended Digital Module input channels support sync input and source input. In this case, the S7-200 Smart PLC is adopted with source input. 1M is connected to 24V for access, and the current flows out from each input point and then is connected to 0V. Instruction system. Standard contact instructions. The LE normally open contact command represents a normally open contact instruction connected to the input bus, that is, the start of the normally open contact logical operation. The LDN normally closed contact command represents a normally closed contact command connected to the input bus, that is, the start of the logical operation of the normally closed contact. AN normally open contact command, used for series connection of a single normally open contact. AX and normally open contact command, used for series connection of a single normally closed contact. O or normally open contact command, used for parallel connection of a single normally open contact. ON and normally open contact command, used for parallel connection of a single normally closed contact. The data type of variables in the LD, LDN, A, AN, O, ON contact instructions is Boolean bool. Two instructions, LD and LDN, are used to connect contacts to the bus, and AN, O, and ON instructions are repeatedly used many times. However, when it is necessary to connect two or more contacts in series to connect circuit blocks in parallel, the OLDB instruction described later is used. A parallel connection instruction OLD for series circuit blocks. A circuit in which two or more contacts are connected in series is called a series circuit block. When series circuit blocks are connected in parallel, LD and LDN instructions are used for branch start, and OLD instructions are used for branch end. The series connection instruction of parallel circuits ALD. A parallel circuit with two or more contacts is called a parallel circuit block. When the parallel circuit block of the branch circuit is connected in series with the previous circuit, the ALD instruction is used. The LD and LDN commands are used at the starting point of the branch. After the parallel circuit ends, the ALD instruction is used to connect it in series with the previous circuit. Output command. The output command corresponds to the coil. When the contact circuit of the driving coil is turned on, the coil flows through energy flow. The output command should be placed on the rightmost side of the ladder diagram, and the variable is bool type. Set and reset commands S, R. S is a set command to keep the action. R is the reset command, which keeps the operation reset. The image registers of endpoints starting from the specified position are all set or reset. N equals 1 to 55. If the timer bit or counter bit is specified to be reset, the current value of the timer or counter will be cleared. Transition contacts EUED. When a positive transition contact detects a positive transition, the input signal of the contact transits from 0 to 1. Or when a negative transition contact detects a negative transition, the input signal of the contact transits from 1 to 0. The contact is turned on for a scan cycle. The symbols of positive or negative transitions are EU and ED, which have no operands. The P and N in the middle of the contact symbols represent positive and negative transitions respectively. Null operation command NOP. The null operation command makes the step sequence null operation. The program end instruction END. END is a one-step instruction without a target component. The PLC repeatedly performs input processing, program operation, and output processing. If the END instruction is written at the end of the program after END will no longer be executed, and the output processing will be performed directly. Design and fault diagnosis of PLC control systems. Analyze the controlled object. Analyze the process and working characteristics of the controlled object. Understand the cooperation between the controlled object's machine and electricity, and determine the control requirements of the controlled object for PLC control system. Analyze the control requirements according to the manufacturing process, such as the actions that need to be completed, action sequence, action conditions, necessary protection and interlocking, etc. Operation mode, manual, automatic, continuous, single cycle, single step, etc. Determine the input-output device. According to the control requirements of the system, determine the input devices, such as buttons, position switches, transfer switches, etc., and output devices, such as contactors, solenoid valves, signal indicators, etc., required by the system. Accordingly, determine the number of input-output points of the PLC. Select PLC, including the selection of PLC model, capacity, input-output module, and power supply. Allocate input-output points. Allocate the input-output points of the PLC and draw a connection diagram or correspondence table between the input-output terminals of the PLC and the input-output devices. Can be combined with Step 2. Design software and hardware. Carry out PLC program design and conduct the hardware construction such as the control cabinet, console, and on-site construction. Because the program and hardware design can be carried out at the same time, the design cycle of PLC control system can be greatly shortened, and for the relay system, all the electrical control circuits must be designed before the construction design can be carried out. The steps of hardware design and on-site construction are as follows. Design the electrical layout diagram and installation wiring diagram of control cabinet and operation panel. Design the electrical interconnection diagram of the parts of the control system. Carry out on-site wiring according to drawings and conduct inspection. Online debugging. Online debugging refers to carrying out online system debugging of the program that has passed the simulation debugging. Sort out technical documents. Include design instructions, electrical installation drawings, electrical component schedules and instructions for use, etc. Let's take a look at the actual operation. This is the physical wiring diagram of PLC, the input and output allocation table. The wiring is strictly based on the signal table. First, connect the 24 volts power cord and the 0 volt cord. Connect 24 volts to L+ and 0 volt to M. Connect the input signal terminal. 1M is connected to 24 volts input, source type. PLC is the signal source. I0.3 to I1.6 is connected to each sensor, and then connected to 0 volt after passing through the sensor. When the sensor is turned on, the current flows from the PLC through the sensor and back to 0 volt. When there is current flow, the PLC collects the current signal and the storage signal. Finally, connect the output signal, the O terminal. 2L+ and 3L+ are connected to the 24 volts power supply and provide 24 volts power supply to the output relay. Connects M to 0 volt. The current flows in through L+, outputs through the output O0.0, O1.7, getting a signal, 1 with power, and OV returns to form a closed-loop current. Please think about the role of each line in the I/O allocation table and explain their respective functions and the logic behind them. In this lesson, we have studied the functions and applications of the programmable logic controller, including recognizing the PLC, wiring, debugging, and other key steps. Through practical demonstration and in-depth thinking, you not only mastered relevant skills, but also deeply understood the importance of sense of responsibility. I hope you can continue to carry forward the spirit in your future study and work and make greater contributions to China's engineering and technology undertakings. Finally, please think about this course and complete the following exercises, aiming at consolidating the knowledge points you have learned today and further deepening your understanding. This lesson ends here. See you next time.